This video is going to help us review for our upcoming tests on transformations. So to start with, we started looking at translations, which is another way of sliding a figure. All right, so if I want to translate the following triangle along the vector -2, 3. -2, 3. So remember, the first one is always x, and the second one's always y. X is always talking about left and right, and y is up and down. So a -2 in a horizontal direction means left 2. A +3 in a vertical direction means up 3. So I'm going to take all my points and go left 2, up 3. So, oops. This one's going to come up here. That's my C prime. Go left 2, up 3, maybe. There's my attempt at a dot and A prime. And 1, 2, 1, 2, 3. There's B prime. All right, a translation is an isometry, so when I'm done, my pre-image and my image should be congruent, just in a different spot on the plane, which in this case they are. Then we looked at reflections. Right, we looked at several different lines that we can reflect across. Right, for this example, we want to reflect the triangle over the line x = 2, followed by a reflection over the x-axis. All right, so I'm going to start by doing x = 2 and then the x-axis, which means this is going to be a composition, more than one transformation. All right, the first thing I'm going to do is do a dotted line for x = 2. Okay, x = 2 is a vertical line. Right, I go to 2 on my x-axis and then draw a line the opposite way. All right, so here's what I'm reflecting across. Anytime you reflect across a horizontal or vertical line, you can count. All right, so you just want to see how far each point is from your line of reflection, and then you're going to mirror that on the opposite side. So if I start with C, C up here is 2 away, so I'm going to keep going 2 on the next side. And that's my C prime, maybe. All right, then A, also 2 away. I'm going to go 2 on this side. There's A prime. And then B is 3 away, so I'm going to go 3 on the opposite side. And it does not like me. Draw my triangle. Okay, again, my shapes should be identical. They should be congruent, right? But now my new image is facing the opposite way. Okay, if you imagine putting your pencil right down the middle, right? Your shapes are going to be symmetrical. It's going to be the exact same on both sides of your line of reflection. Okay, so that's A, B, and C prime. Let's change colors. All right, the next thing I want to do is reflect my A, B, C prime over the x-axis. Okay, the x-axis is the horizontal one. Okay, you got the rule for the x-axis where x stays the same, y changes. Okay, but if you're just looking at your graph, you might as well count. The x-axis is another horizontal line. All right, so A prime is 1 away, so I'm going to come 1 down and put my A double prime. C is 4 away, so I'm going to come 4 on the opposite side. C double prime, and B is 1 away, so I'm going to come 1 on the opposite side. B double prime. All 3 of my triangles are going to be congruent because a composition of isometries is still an isometry. All right, so if I did a reflection and then a reflection's an isometry, so my entire transformation is going to be an isometry. Then we looked at rotations. Okay, remember we rotate 90, 180, and 270. All right, if it doesn't say otherwise, we're automatically rotating counterclockwise. Right, for this example, I want to rotate 270 clockwise, which means I'm going to have to use my rule for 90 counterclockwise. All right, and that rule is -yx. Okay, whenever you're talking about rotating, you need to go ahead and write out your points. Okay, do not try and count, do not try and guess. All right, so A is at 1, -4. B is at 4, -4. C, 4, -2. and D, 1, -2. Oops. Ooh, I don't know what that is. 1, -2. Sorry about that. All right, and then this is going to map onto my whatever I find using that rule -yx. So I'm going to flip x and y, but change the sign of y. All right, so then if I flip, this would be -4, 1, but I'm going to change that -4 to a +4. This one, -4, 4, change that -4. C, -2, 4, change the -2. And D prime, which actually this should be 1, -2. Goodness gracious, this thing doesn't like me. 1, -2. All right, terrible. Apologize. 1, -2. All right, if we flip them, it's -2, 1. Change the -2, +2, 1. All right, so then if I go to graph this, A prime for 1, B prime for 4, C prime 2, 4, and D prime 2, 1. All right, not such a great drawing. But again, you can double check your work with rotating by turning your paper 1 click. Right, 90 degrees is 1 click, 180 is 2, and 270 is 3. So you can always kind of guess or gauge where your shape is supposed to be on your coordinate plane and kind of check your work. The last transformation we looked at is a dilation. Okay, a dilation is making it enlarge or reduce based on the scale factor. Okay, so I'm going to dilate this figure using a scale factor of -2. So that negative just tells me it's going to be reflected, and the 2 tells me it's going to be an enlargement. It's going to get bigger. Now this one, it's pretty nice and gives us all the points. So I'm just going to write them off to the side. A at 2, 3, B at 5, 4, and C at 3, 7. Anytime you're working with a dilation, all you do is you multiply your scale factor. So A prime, if I just multiplied both by -2, would be -4, -6. B prime, -10, -8. C prime, -6, -14. All right, which is probably going to go off our screen, but now I'm just going to graph them. So I've got -4, -6, maybe. There's my A prime. Got -10, 6, 8, 10, -8. All right in here, maybe. Ugh. There's my B prime, and then -6, 2, 4, 6, and 14 is going to go off. 2, 4, 6, 8, 10. We'll have to do some sketching. We'll say that my 14 is right there. It's not going to be exact. You should be able to fit it better on your graph, but I can't on the screen. All right. So if you kind of imagine flipping the red triangle and then making it double the size, we would end up with the purple. Okay, one thing to keep in mind is your pre-image and your image will always be collinear with the origin. Right, which means if I were to draw a line, it should go through A and A prime. Another one should go through C and C prime, and B and B prime in the origin. Okay, so if you get one that's kind of way off to the side and it won't go through the origin, you know something's off. And then we looked at compositions. Okay, remember compositions is doing more than one transformation. Okay, we looked at a couple specific ones, some rules or conclusions we were able to draw. Right, so what single transformation would be the same as reflecting a figure over y equals x and then y equals -x? Okay, so remember, if you think about what those look like, y equals x is the positive diagonal, y equals -x is a negative slope diagonal. Okay, anytime you reflect over intersecting lines, you need to look at the angle between them. Right, I know that this has a slope of +1 and this has a slope of -1, which tells me that they're going to be perpendicular. Perpendicular means they have a right angle. Right? So then what we found out in class was that reflecting over intersecting lines is the same as rotating twice the angle between them. So if it's 90 degrees, it's going to be the same as rotating 180 degrees. Okay, so rotating 180 degrees. And then we say what single transformation would be the same as reflecting over the y-axis, and then x equals 4. Well, if we think about graphing that, the y-axis is the vertical one, x equals 4 is a vertical line at x equals 4. Okay, the other conclusion we were able to draw is that reflecting over parallel lines is the same as translating twice the distance between them. Right? These are both vertical lines, so they're parallel, and they are 4 units apart, which means it's going to be the same as translating, translate 8 units, and in this case, we're going to go 8 units to the right, because we're going from the vertical line here to the right this way. Right, so to go from the y-axis, x equals 4, going to the right, so we're going to translate our shape to the right. And that's it for this video to kind of help sum up a lot of the stuff we've looked at in this unit.